Yeah, seems quite so.
The models which they're released in open source. So OpenAI is now being, sometimes people say it as closed AI also for fun, but then they release this in open source, and basically they release the model weights and the corresponding inference code in September 21, 2022. So what is Whisper basically? I asked Bing GPT this question, uh, and it said this: Whisper is a computer program which can listen to people talking and write down what they say. So what that basically means is like Whisper is a speech-to-text system, and it is an ASR system, and it is called in technical terms, people call it as automatic speech recognition system. And another thing which it said, Bing GPT said, was Whisper can understand people speaking different languages and can even translate what they say into English. So what that means is like Whisper is not just trained only on English or something like that. It is specifically trained on almost 99 languages. It is a robust ASR model, and it is not just only for ASR. That is the even funny part. It can do translation, language identification, and a few more tasks. You can check the Whisper paper to know more. So these are the Whisper models they released in the open source. And let's look into some of the features of Whisper. Whisper performs phenomenally well in English speech recognition. So this is a picture from their paper, and you can see that they have compared company A, company B, and all, because they can't reveal the companies when they do it in the paper. And also NVIDIA STT was like the state-of-the-art system previously before Whisper in the open source world as well. So you can see that it is performing phenomenally well in English. Another thing is like Whisper is trained on 99 languages, but even though if it is trained on 99 languages, I won't say it is performing well on all the 99 languages. Probably it is working well in 57 languages at the moment, because that is what they, in the OpenAI Whisper, which API which they have released, they just support 57 languages. Another thing is like that they have released this in open source, right? So once they release this in open source, one awesome developer, Georgi Gaganov, he created an open source project called Whisper.cpp. It supports a lot of platforms. So now Whisper, which was a very large model, can be run in even small devices like Raspberry Pi and lot more devices at the moment. And Whisper has a lot of amazing community plugins because it was released in the open source. So I'm not going to explain all of this in the talk. So since I'm assuming, who all know what is fine tuning in the audience? Okay, so this is a relatively new audience, so I'll just try to explain a bit more in depth. So if you are an open source, one of the best courses to start learning AI is what I always recommend is called Fast AI course, and this is what Jeremy Howard usually teaches. So let's say we have a large model. So most of the time we have some large model, like large pre-trained model, which is being released in the open source world. by companies like Google and stuff like that. And then basically, if you want to work on your smaller subsection of data to get good results, you collect the data, and corresponding to that, you train it on your particular data. So if you look at in this example, so we had a language model which is trained on Wikitext 103, which is like a text data set. IMDb is a smaller data set, which we want to perform really well here. So we collect the data in the IMDb and train a language model for it. And now if we want to, like, it was a language model, but if we want to work very well for classification task or something like that, we can do it. So that is basically what fine tuning means. And I just wanted to say that fine tuning is the new training, because at the end of the day, not a lot of people like me or something, we are not very rich or something, so we can't afford to train models in OpenAI scale or Google scale or something like that. So what we can do is fine tuning only most of the time. And in this fine tuning, it is a very common practice for a long time in image classification, especially in computer vision domain. But now it is getting more and more relevant in audio domain. It has been more and more relevant in the NLP world. Even it is getting more and more relevant in the chat GPT, in these big LLM models as well in the future. That is what I see. So you may be thinking, why should we fine tune Whisper? So you should only fine tune Whisper if you are not getting good results with the Whisper model weights which are released by the community. So if you are already getting good results with your Whisper open source Whisper model weights, no need to fine tune. But if you are getting really bad results in your particular task, you need to do a fine tuning, and sometimes it might improve the performance. So how to do fine tuning in Whisper? So I won't be covering it, but basically it is well covered in this fantastic article written by Sanjit Gandhi of the Hugging Face team, and he has basically explained the steps for doing it as well. I won't be covering it in my talk. Once this particular article was released, there was an event which was organized by Hugging Face team. So Hugging Face team organized this event called Whisper event, and it was an event to achieve state-of-the-art results in languages, low-resource languages like in Malayalam or small languages. There are a lot of languages where like Whisper is now performing really bad. So it was an event which was conducted to get to train some new models, and they even gave some GPU credits as well. Almost 100 hours of GPU credits was being sponsored by a company called Lambda Labs as well. So yeah, it was great. And for Malayalam, fortunately, we got a lot of good models. So because of that, these many models were being released in Malayalam. And the winning models in Whisper event was 10L Whisper Medium ML, as well as for Fluors, which is another data set, it was Param Bharat's Whisper Small ML model. But personally, I was not really convinced with the results of the Whisper event. The reason was because in Malayalam, achieving 10% word error rate is wow. If it is ever happening, we can use it in production. So I wanted to check this hypothesis. Okay, can we get this particular results? And we don't have much yardsticks as well. Like no one has done such a benchmarking exercise. So no one doesn't know, okay, for this particular data set, what is the result at the moment or something like that. And another thing is like Malayalam, unlike English or something like that, is a highly morphological complex language. In this link, I have linked a research paper which basically mentions that. So even achieving 30% word error rate or something like that is a big thing. And another thing was because I'll just show you here also. So the way Hugging Face evaluated the model was something which deeply, it felt wrong to me, because in the model card, someone basically put the word error rate. It is like they had in the step, they automatically generate and calculate a word error rate based on the validation data set you have used. But if you look here, I think I'm not able to show that commit. So basically, this is the 10L's Whisper medium model. And if you look here, the word error rate was 38.6207, while in the leaderboard, you see, his results was 11.49. Anyone can edit a readme and he could have got good results. That is, it's something deeply suspicious for me. So I thought of building something new. So I created a new project, GitHub project for doing Malayalam as a benchmarking. And when I just tweeted about, I have been working, and then I just said, I just benchmarked first on a very small data set called Common Voice data set. And Kavya Manohar, who is a speech researcher who has been working in Malayalam who has been doing her PhD for 5 years, said, you know, no one has done this before, Kurian. Thank you. Because there are so many ASR papers in Malayalam, but no one has ever tried to do a benchmarking so that to validate stuff here. So, so at the moment in this talk, I'll be trying to present the results of benchmarking in Malayalam. So we had these models and we compared it with the 6 model versions released by OpenAI. So this is how my model results would have been with my benchmarking tool. So if you look, I calculated the model name, the word error rate, the CER, the model size, and the time it took for the model to run in that particular data set. So obviously smaller data sets will run, smaller model versions will run faster, while larger models will obviously take time. And these are the results. OpenAI's Whisper models, if you look at the result, the word error rate, which I forgot to explain, which is a metric for calculate similar to accuracy in ASR world. In word error rate basically means like we always calculate word error rate as 100 minus word error rate is equal to accuracy. That is the formula for accuracy. In Malayalam, you see OpenAI's models, it is like 0 percentage, minus 50 percentage, and stuff like that. So Tunnel model achieved good performance here. It got 11 percentage results. And for common voice dataset also, for another metric, character error rate, which is equivalent to word error rate, some slightly different, you can see that from 180 percentage to 5 percentage. And another dataset which I benchmarked was Malayalam speech corpus dataset. So if you look, this is the model names and the same result itself. And in Malayalam speech corpus data also, from 139 percentage to 2% with fine tuning. Same here, 177, 200 percentage to 1%. So I have almost reached the end of my talk. I just have proved that like fine tuning in Malayalam can achieve great results. So, if such a model really exists, and if we want to do more and more benchmarking, obviously, this is just early start of this project, and I have just started working on it maybe 2 months or 3 months back. Just thought about working on this. Um, we got very good results in Malayalam. Previous state-of-the-art result with other methods as well, not just with Whisper, is almost the word error rate was 80 percentage in Malayalam speech corpus dataset. That was the only thing I could find when I tried to research something. It is very hard because there are not a lot of researchers who are working in small languages like Malayalam. So, and since we got phenomenal results in Malayalam, if you're working in a low resource language, if you are a speaker of a small language or some other language, you can also get amazing results by fine tuning. I think that's all, and I want to thank all these people for doing phenomenal work and helping me out. And finally, I want to end my talk by offering tributes to Arif Jamal. That's all. Thank you.
Thank you so much. I don't think we have much time. Maybe might take one question there.
Okay, so in India, basically there are two types of languages, like Devanagari language as well as Dravidian languages is what I think. So I'm not an expert, I'm not a linguist, so I may be wrong here. Uh, Malayalam is one of these Dravidian languages, and Dravidian languages in India, basically spoken in the southern part of India, Kerala, Tamil Nadu, Karnataka, Andhra Pradesh, Hyderabad, Telangana all speak these Dravidian languages. But then, you may be thinking like, okay, even though it is a Dravidian language, Korean, are you be able to speak in Telugu or some other language? I don't even know any word in Telugu or something. I can speak a bit in Tamil. That's all. So it's all languages are unique on its own. And Kerala, we have a population of 3.5 crore people. So 3.5 crore people, I don't know in English how much people will be like. This is what I said in Indian numerical language. But there are a lot of speakers for our language, and we are fairly a large language with a lot of population, obviously. But then, unfortunately, not a lot of people are working in this language, obviously, because profit and all those things. When we are working, we just have a few volunteers who are working on our free time to do something for Malayalam. That's all. Yeah.
All right. I guess with a lot of languages in India, to your question, right, there's probably a lot to be done in being able to optimize and introduce these into your language modules. So thank you very much, and I really appreciated the sharing here. Thank you. Goodbye. Thank you. Right, so I see the room is filling up nicely, which is great. Just trying to have a look for our second speaker this morning.
Good morning, everyone. Okay. Sorry for the technical problem. Uh, Today, I want to talk about the open source and explainable AI. And then I'm a master student, and actually, I just finished my thesis, and I also research assistant in the FKI, or German Center for Artificial Intelligence. And then today, I want to share about the open source and explainable AI. And then I have a little story when I was working on my thesis, and which is the hard part of my life because a lot of things to do in the research lab. And then but I got a lot of help in the open source software. So when I looking for something, I just see, oh, I got this on the open source, and then I got a lot of things in the open source. So I feel that I need to contribute back to the community. So I just want to share the knowledge to the community, especially to the open source community. And then I want to share about the open source and explainable AI. Okay, before we are going to the explainable AI, we know that since the era of deep learning, AI or artificial intelligence has had a strong open source traditions. Many important models, datasets, framework were done in open source way. And then the open source is the important part of the development of the AI technology. And then there are several things why the open source is important. And then when we use the open source software, we have a more control, which we are to which we are able to examine the code and change part of the code. And we can also use this software for any purpose that we want. And then we can also study and learn from the expert by looking at code which publicly available. And then we can also share the knowledge to the other person, to the community. And we can also avoid the same mistakes to which the other persons get. And then it makes us learning, and it is a place for training how to make a better software and AI system. And then the open source also more secure because anyone can view, modify, and correct the error on the code. And if many people contribute, the issue can quickly fix and update it. And moreover, the software also stable because the code is publicly available or publicly distributed, and it is fit for the long-term projects. And then the last one is the community collaborations. And in Open we usually produce, test, use, and promote software that we loved. And then the open source has a long history, and this is a brief, memorable milestone. And then learning the history helps us to understand the past and the current state of the open source software. And then when we look back to the history, the concept of free information sharing in the technological ecosystem existed long before the computer itself. And then it's from the automobile industry in 1911. Henry Ford, or the Ford automobile, won a challenge against the patent which tried to monopolize the automobile industry. And Henry Ford led the way the era of open collaboration, especially in the automobile industry. And then during 1950 until 60, the widespread use of sharing code, sharing source code was high. And most of the software produced by the academics and the lab, which has a long-standing traditions of open sharing and collaborations. And then in 1969, ARPANET, a precursor of the internet, was released. It leads the easier exchange of the software code using the internet network. And then Linus Torvald in 1991 released the Linux with a fully modifiable code with GNU license projects. And then in 2005, a simple versioning control like Git released to the public for software projects. And then since the era of deep learning in 2012 until now, AI has a strong open source traditions, and many important AI system, framework, model, and dataset were done in open source way. And then when we look over the last few years, the widespread use of deep learning and artificial intelligence has experienced significant growth. And we also have more than 17 billion devices with a trillion of sensors are connected to the internet. And they continuously generating streaming of the data. And the AI system can use this data and automate the process of decision making. And AI systems also improve rapidly in their performance, such as in language understanding, image recognition, speech recognition, and etc. It also impacts many aspects of businesses, companies, and organizations. And then many companies and organizations want to leverage the AI system, but it is not easy to trust the machine to take the decision, especially in the domain that need a human expert, such as in the healthcare, transportation like a self-driving car, and law and other sectors. Sometimes the decision result is not too important rather than the process of creating the decision itself. And in some recent model, like a deep neural network, and we can only see the input, the model, and the output, but we don't have any knowledge about the internal process of it. And this is called the black box problem. Now we take a look at the black box problem. In a black box problem, in AI refers to the issue of understanding how machine learning choose a specific decision or predictions. In many cases, these models are complex, meaning that it can be difficult or even impossible to determine the reasoning behind their output. For example, in here, the first image is cat, not a bottle. But we don't know how the machine said that this is a cat, not a bottle. Uh, but even this image contain both cat and bottle. And then in the second example is in a self-driving car. In machine, the machine just stop. But there is no explanation why the machine just stop. Is there any pedestrian or car which detected in their LiDAR sensor or etc.? And why the car chose a specific decisions? So the lack of transparency in our model can be a significant issue in the field such as healthcare when the stakes are high and decisions need to be justified. In the medical image shown here, is this benign or malignant cancer? The decision of our model can also lead to error, bias, and discriminations, as it might not be clear why certain decisions are being made by our AI system. So, to address this black box problem, we need explainable AI model. It can make a better transparency and explainability in our AI model. And then explainable AI refers to the techniques to make the decision result of the AI system can be explained and be understood. Explainable AI can help expand utilizing AI system in a critical and sensitive domain where several criteria must be met, besides only the high accuracy. And it different from the black box concept, which cannot explain why this model chose the specific decisions. And then when facing the real problems, the challenge is not how to build a complex and sophisticated model, but how the machine can be understood by the human. And consequently, the transparency and explainability of our model become a critical factors. Thus, we need transparency and explainability in our AI system so the human can understand why and how the model chose a specific decision, not only just the accuracy of the model. So the user in the future can understand why the model chose specific decision and why not. And they will also know when it succeeds and when it failed. They will know when to trust the machine to take the decisions and know why the machine learning algorithm got an error. And then when we talk about the machine learning algorithm, there are several machine learning models. The deep neural network, for example, offer enormous advantages in terms of their accuracy, but they lack the ability to explain their results. The degree of explainability, the higher the quality of the results, the harder the model to explain. And then the lower the quality of the results, the easier model to explain. This graph shows the model performance versus the model explainability. And most widely used algorithms of machine learning are depicted here. And then from the simple model, like a rule-based model, a linear model, and decision tree, until the complex model like a deep learning, GAN, CNN, and RNN. The ideal solutions is to get high explainability with a high performance. However, the easier to explain the model, like a linear model, rule-based model, and decision tree, the lower performance in those in general. So in contrast, when we see the complex model, like a deep learning and ensemble model, they can achieve higher performance, but it's hard to explain their decisions. And then several methods of explainability has been proposed in deep learning model. One of them is saliency map. Saliency map is an important concept of deep learning and computer visions. And saliency method explains the decision of algorithm by using the input component. It assigns value that reflects the importance of the input and their contribution to the decisions. The saliency usually use a heat map. It will show the hotness level of the regions that refer to the image, which have a big impact on prediction to the specific class. And then the example of saliency map, like a class activation map, GradCam, LRP, and etc. In healthcare, it can be used to process the medical image. And in robotic, we can use the object detection and etc. It can also be used in the self-driving car to detect the car and road and etc. And then next, we are going to the new trend of the AI, the generative AI. The generative AI is a class of machine learning that can learn from the context such as text, image, audio in order to generate new content based on the input prompt. In contrast with a common machine learning algorithm, which learn and produce the decisions, the generative AI produces artifacts as an output, which can have a wide range of variety and complexity. The generative AI has a large number of parameters. Moreover, the generative AI are able to process multiple prompt modalities. When we see in a depth, many of the generative AI use models like a generative adversarial network or GAN, variational autoencoder, RNN, and transformer model. And then the image shown here is the transformer model. And then the transformer model is a deep learning model that adopts the mechanism of self-attention. And then differentially weighting the significance of each part of the input data. And it used primarily in the natural language processing and computer vision. And then the core component of the transformer is the embedding layer, attention, and feed-forward blocks. And the attention block map the input into the query, k, and value, and matrices, and split into the array of heads, and the multiple heads concatenated and create the multi-head attentions. So the important question is how we make explainability in generative AI based on the transformer. And then explainability in generative transformer have become increasingly complex with a large number of parameters and their ability to process multiple prompt input modalities. When we see the generative AI which is based on the transformer, we need to check the explainability in their model. Through their increasing size, transformers are exceptionally challenging for the explainability. However, the most explainability adoption in the transformer focus on their attention in the last slide. And then let's take a look at the first image in here. Is the example of the explainability based on the cross entropy score. It shows the probability of the next word prediction value using the cross entropy. And then the second image is here is the example of the multimodal prompt. When we prompt the image in here, the generative AI will answer the content of the image. The example of the answer content is a lonely cabin on the edge of the lake with a truck nearby and the kids. Each of the answer also show the heat map image, which highly contribute to the specific answer. And when we use the image generations. But in top of that, it's still open research problem. And then so the last thing in these sessions, I'd like to take a giveaway for the community. The community, especially the open source community, has a bigger role. And the explainability AI try to solve the black box problem in the machine learning. And we as a community can contribute together to make a better, safety, and trustworthy in our AI system. We can also building a foundation of an AI system for the future, same as the Linux era, which come from the open source community, and it become the foundation of the modern technology nowadays. And thus, there is a chance for constructing the foundation of the next generation of computing with an AI with the open source community, building safety, transparency, and reliable for the future of the technology. Thank you.
Thanks for that. Thanks for that. Any questions? Open to taking a question, but otherwise we'll take that offline. So, Ahmed, thank you very much. And yes, thank you all. Okay. Good. I hope everybody's having a good morning so far. Coming up for 10:30. I think we had a bit of misalignment in the diary earlier, but the next speaker is definitely on time. So we're kicking off with Ms. Vadisvaran Archana, and they'll be talking this morning on a topic specifically to unlocking English writing for everyone, building a ChatGPT Chrome extension for improving English writing accessibility. I think you all have the summary, but really about going through this in motion and demonstrating practically how they've built this extension and how it can benefit the users. So Archana, I'll hand it over to you. Introduce yourselves.
Sure. Thank you so much. So yeah, hi everyone. I hope you had a good breakfast. I know it's like a bit early in the morning, but yeah, I'm really excited for this talk. I don't think this is the first time you're hearing ChatGPT this week. So I think as we delve down, you'll learn more about it and also learn about, our progress as such and what we learned throughout this process. And so, yeah, let me go ahead. So I'm Archana. So I'm currently a data product manager with Women Who Code. I'm wearing their very cool shirt as well. And if you do come to the event hall, I think you can catch our booth, both Women Who Code Seoul and Singapore. And apart from that, I'm also a board member with Women in Machine Learning, which is another nonprofit. And yeah, I also produce courses on LinkedIn Learning. I have one on learning TinyML, and we have another one coming out on MLOps with Vertex AI. That's maybe coming out in a month. Both of us have produced that. And yeah, I'll let Soham go ahead and. No, it's okay.
Yeah, hi, I'm Soham. I'm currently the machine learning lead at a startup in Singapore called Sleek.
So yeah, as I said, probably this is not the first time you're hearing ChatGPT this week, and so this is a short preview of what we made. I hope this sort of makes sense, and you know, as we dive into it, I know that we can't really walk you through exactly, how we build, but we can in the 25 minutes. But for sure, we can give you the access to the GitHub and so on. And so yeah, so today's agenda is what are we building today? A peek into like GPT as such. And most importantly, we want to talk about what they don't tell you about building these LLM products. And then finally, like ways to contribute. So yeah, let's start with the first thing, firstly, yeah, we've definitely wanted to try our hands into LLMs. But most importantly, like, most of us here, maybe like even me, right? I speak 3 languages. So in my head, I'm always translating between all of them. So yeah, one of the things that I oftentimes face is English accessibility problem, right? We oftentimes convert the text to English or in our head or otherwise, and maybe it doesn't sound right. So I thought this is like a perfect example for ChatGPT to help out with. And so I went, like, I tried to figure out, like, on the web, like, if there are people similar to me. So there turns out it is. So do you know that more than, half of the world's population speaks at least 2 languages, and many people tend to think and work in their native language? Over 75% of consumers prefer to buy products in their native language, highlighting the importance of language accessibility. And 50% website visitors will leave if they can't read or understand the context, and indicating a significant barrier for non-native English speakers. So in short, long and complex English texts can be difficult for many people, including those with reading or learning disabilities, elderly individuals, or individuals with limited English proficiency. So yeah, I think this is a great segue into talking about GPT.
Um, just trying to make it easy for people to, for bilingual people to, and people who speak more than one language to, um, talk in English, write in English, and also, like do communicate business English better. And we're trying to do that with GPT. So I'm sure you've heard of ChatGPT by now. What it is it's a language model that was created by OpenAI. I think GPT is like the most famous one right now, but there's a lot of others that people are working on. The biggest language model that I think has been released so far is GPT-4. It's been trained on data till September 2021. And a really cool thing about these models is they have this thing called emergent abilities, which is they can do tasks that they have not been trained on, and they can generalize across a lot of different tasks, right? And GPT, how it was trained to do this was take feedback from humans and learn how humans want the GPT to answer questions, and GPT will kind of try to emulate that, right? So how you interact with it is through natural language, and it also replies with natural language. But the problem with GPT models are that they're very large. I think anything more than GPT-2, which is 1.5 billion, it's pretty much out of the realm of startups, open source companies, and even mid-size companies to train. And if you want to deploy them, you have to kind of deploy them on GPUs, sometimes even multiple GPUs to make sure that the latency is less, right? But it's really good at so many tasks that these models right now serve as kind of like a baseline or a benchmark when you're trying to build new tasks, and that's why you can't really ignore them at all right now, and you have to use them. And I'll talk more about that in some time. But yeah, so we saw this, we got really excited. We saw a lot of other people building products with it, and we thought, okay, let's try building something. It seems pretty simple. And we'll just make it open source, we'll deploy it, and hopefully learn a lot of things along the way. So yeah, that was like the first step. So we started building, and it's really easy using GPT to go from 0 to 1 and build something that's modestly reliable, and it works pretty well. And you can do that using something called prompt engineering, where you create these natural language text prompts that tell the model what to do, and it'll it works most of the time. It replies with what you want it to reply, right? But then you know it's different when you're trying to build like a pet project that you might use from time to time or demo at a few places, and GPT works really well at that. But when you try to take that to production, that's when other problems come up. Problems like cost, right? How much it takes to run these models, latency, how long it takes to get a response from the model, and also how reliable and scalable the solution is, right? And this is like stage 4, where we are super impressed by the capability of the model, but also it kind of lacks in a lot of ways, and it's not reliable and it's expensive, right? And that's the point where you get really overwhelmed trying to fine tune these prompts, trying to make sure the costs are less, the latency is less. It's really difficult to make that work. So yeah. Before I move on to like the problems and stuff, there's also another issue, which is because this field and these kind of models are so new. There's not a lot of standards or best practices for how to even go about deploying them, right? So that's also something we're trying to learn while building this. Right now, our architecture is like really simple. The extension connects to like the extension backend, which sends a request to our Python backend, that connects with OpenAI's API, and it sends back the result, which goes back to the front end. Both me and Archana, we've worked our whole lives in backend in Python. We have like very little JavaScript or front end experience, right? I can't even center a div in CSS. So the front end as well as the JavaScript backend for the extension was actually built using ChatGPT, and it took us like an hour with like almost no JavaScript experience. So yeah, so with that, I want to talk about like some of the challenges that we face while building this. I think the biggest challenge is issues with the API. OpenAI has like kind of openly, like they've come out and said like, we have no SLAs for our product, for our API. We have no latency or uptime SLAs. And they'll be really happy to randomly deprecate models and just deprecate models, right? So when we started building this, we were building this on on the DaVinci 002 model. We created a few prompts that were working really well, fine-tuned them to make them work better. And then a few weeks into the project, they said that they're deprecating that endpoint, and you should now move to this new endpoint. Transitioning to the new endpoint, it's easy. You just change where you're calling how you're calling their API. But the prompts, they don't work as well anymore. Right? The prompts are not as reliable. Sometimes they don't give the kind of outputs we expect. And so we had this really well built, fleshed out product, but then we couldn't transition to the new API, and that would take a lot of effort. At the same time, when they released this new this new endpoint and this new model, I think they stopped putting resources into their previous model, the one which we had built our product on. And so our latency increased from like a few seconds to like minutes, right? And that that just makes the whole thing really unreliable. And as someone who's trying to build products around this, unscalable as well, I think. Another issue is with prompts and how you engineer prompts. So because you're talking to the model using natural language, it's ambiguous. You can infer lots of meanings from it. And so prompts are also ambiguous, right? And it's very hard to get reproducibility, very hard to get the same result from the model even using the same prompts. And the model also tends to hallucinate, and which is basically like it'll tend to make up answers or give you wrong answers, but it'll do that really confidently, right? Um, which is also an issue, right? Because how do you even serve like the result of your of the model if you're not sure how confident you should be of that result? Um, and you know, as these products get more complex, what you do is you chain like results from one model to another model, and then that gives a different result, and then that goes on. And you also have like agents, which is like models that can do some tasks. So maybe like, you know, query a SQL database, search something on the internet, stuff like that. These are really inconsistent. They work like 1/3 of the time at best, right? And if they fail, especially if you have long chains, so let's say the chain fails in between, it's very hard to recover from that failure. A, because you can't tell if the chain has failed in the first place. And secondly, I don't know if you've used ChatGPT, but if you tell them like, hey, you've made a mistake, this is what you should do, it's very hard to get it back on track, right? It'll just say something like, oh, I'm sorry, and then keep making the same error. And there's also no evaluation metrics for these errors, right? Because it's natural language, you can't really evaluate whether the output is correct or not. And finally, like trust and security. So recently, OpenAI kind of took up this like, I don't know, some policy or something where they said that uh, if you can opt out of data collection, especially for training and all, which is great because that was a big concern for a lot of companies. But then the other concern is we don't actually know what data was used to train their model, right? So you know, what if you're building like, let's say, something that does financial modeling, whatever, right? Accounting maybe. And what if that were, or like, you know, like stocks and stuff. What if OpenAI trained their model on data from like Reddit's the Wall Street Bet subreddit, right? You don't want that kind of data in your model, right? Or maybe you're doing like some kind of medical diagnosis, right? You want to make sure your model was not trained on data that consists of incorrect, you know, misinformation or like, you know, malicious information. And then finally, prompt injections and attacks. It's like almost every day that people are creating new ways to, you know, attack these models, make it to act in malicious ways or adversarial ways, and it's very hard to defend against them. So these are some of the challenges, but then it's not that bad. There's still some solutions to it. Um, I think the first thing I want to talk about is like the cost of the model. So when you, I think what OpenAI has done with this is they've reduced the barrier to entry for startups and for companies to actually build smart, intelligent products, right? Because you know, previously you would have to hire like a team of data scientists and engineers to build like any AI machine learning based product, right? And that's expensive, and you don't even know if that product will work or not in the end. So, but what OpenAI has done is it's kind of made it very easy to just write a few prompts and get a product up and running very quickly. But then as your product grows in complexity and as you get new users, your API costs start to like exponentially increase, right? So that's what you see in the first half of that first 1/3 of that chart over there, which is as your product grows in complexity, your costs will kind of skyrocket, and it'll make your business unsustainable. So what you have to do is very quickly move on and fine tune a model. This will also allow you to make sure the model is trained on you know, like more relevant data. So it gives you more relevant outputs. It might reduce incorrect outputs from the model. It might also make your outputs more manageable. And then also it reduces costs, especially if you can deploy that model on premise, right? But the costs don't decrease a lot, because you still have to deploy that model on a GPU, maybe multiple GPUs. And also you have the same problem where even though you might not be paying for an API, if your prompts increase, if your application complexity increases, your costs will increase a lot as well. And so it's at that point that you have to kind of start training a custom model. So what I think will happen in the future is you'll have to do this process of buy while you build out your solution, right? So it'll help small companies, startups challenge incumbents because they can build out products really quickly. So that's the buy versus build problem and solution. Some of the other solutions, so for prompt engineering, what we've seen work is like few shot prompting, which is where you give some context about the problem. And then you provide also some some formats for inputs and outputs that you expect from the model, and that works really well to make the output from the model more organized and easy to parse. And then if that'll work for I think most applications. And another thing that you can do is tell the model to do something called chain of thought. And what it does is you tell it to uh, like run down like the how the model arrived at an answer logically, and that kind of helps the model make less errors. But then you're generating more output, so your latency increases, your costs also increase. That's kind of like a disadvantage. And there's a lot of other techniques you can do after chain of thought prompting, but at that point the costs get so high that it doesn't make sense anymore. You have to fine tune your model after that point. Um, Another thing that's been becoming very popular recently is something called vector databases. So the outputs from these models are like vectors, which are like long matrices of numbers. And so what you can do is instead of querying the API, you can kind of save that vector. And if you have someone ask a similar question, you can query from that vector instead of from the API. It works really well when you have like documents. So let's say let's say you're doing something like a document question answering thing, right? So you may provide so someone may have like a large document and ask multiple questions from it. So instead of sending that document to OpenAI multiple times, you send it once, save the embeddings, and then query from the embeddings, right? Saves costs and latency. Um, don't use chains, don't use agents at all. They're not good at the moment. Anything where the agents are completely autonomous will probably not work right now. That's what we've seen, even with very simple applications. Um, and then another thing people do is like to solve this issue is they have like another model, like a watcher model, which is also another LLM, to watch the original LLM to make sure it's not making mistakes. It works sometimes, but if it doesn't work, you have the same, like snowballing effect where errors lead to more errors, and then who watches the watcher, and it just becomes like watchers all the way down. And then finally, like I want to talk about some best practices that we think you should do. So all of these are also best practices. But then another thing is like these prompts that you create while building your product, they are now like your proprietary data. They are the equivalent of like an in-house deep learning model from like the old days, like 3 months ago. Um, so yeah, save those prompts, make sure they're not leaked. It's very important that that you treat them very as important as like your API keys or something. And then for prompts as well, make sure you version them and you test them. Treat them like you would like any data. And for testing, you have to make sure that the same prompt, the answers don't drift a lot, and the quality of the answers don't degrade over time. Stuff like that. Yeah, so these are some general good practices, but I think we need like more from the community and from other people who are building similar products. And as we also come up with more, we build out our application, we'll share those best practices as well. Yeah.
Yeah, so I wanted to give a quick demo before I sort of progress, because I know like we have been talking a lot about LLMs, and I also want to go back to the product and help you see like how it works. So yeah, over here you can see like a input, and we tried using Chinese. So yeah, yeah, you can see like when it converts, it says good. I'll take the numbers, but it doesn't sound that good in English. So you can take that text again, and you can go ahead and formalize it. So these are the three functionalities that we have with like the Chrome extension right now. It does these three things: is summarization, formalization, and then translate. I want to also show you the GitHub. So we do currently have GitHub to, yeah, like where we have hosted the project. So you can see like the entire project, and we have also like raised up issues where you can go ahead and see those issues and contribute back. Again, like this is completely open source, and we really want people to go ahead and contribute, because that's how it'll help. And most importantly, I feel like both of us have like a tunnel vision where we just are looking at one problem, but there's probably a lot more to explore. And yeah, so this is like a short roadmap we see. Where we are right now is like something functional enough. It does something small. And we do feel like there's a lot more things to figure out. Like tone is, for example, right now only formalized, but what if someone wants to make it fun? Someone wants to change it entirely. So I think it should definitely work out for that as well. And then have like a better user experience. As Soham mentioned, both of us don't have backgrounds in that, and it's taking us time to understand what a customer might think, and it's mostly like how we interact with the extension. So if you're someone who has that experience, we would love for you to contribute. And finally, like we are definitely dependent on the community to take it forward. We are writing more about our journey as such on the newsletter, but definitely like welcome you to also do so. So if you have interested you right now, especially with our LLM rant, I would go ahead and tell you how you can contribute. So there's obviously backend ways that you can help build the product and the API as such. This front end development, as well as I said, improving the front end features. There's newsletter content, and we'll share you the newsletter as well. We're trying to sort of journey this entire Chrome extension, and you can, if you love writing, you can go ahead and send us, and we can for sure put it up on our newsletter. And finally, infographics. The infographic that you saw I created, I feel like making infographics is very soothing. So if you're someone like me, do let me know and do contribute to the infographics. And yeah, reach out to us. And finally, also want to show you the newsletter. So this is our newsletter. It's tinyml.substack.com. We actually covered one yesterday as well about the LLM conference as well. I don't know how many of you attended. It was way in the night, but yeah, you can also check that out. And Soham's latest, whatever he told you right now in a blog format. So yeah, that's pretty much the end. But yeah, feel free to ask us questions. I know like this topic seems very complicated. I mean, I feel like GPT definitely, like OpenAI definitely has made a great interface to interact with it, but what happens behind the scenes seems quite complicated. And we also started out like, only a couple weeks ago. So, feel free to ask us questions. Don't worry about your questions sounding naive or something, because, we also started off, if nothing, it can, your questions can also help us, and vice versa. So yeah, does anyone have any questions? Yeah, hi.
Yeah, you mentioned about vector databases. In a question answering app, how would you go about matching the query to a saved vector?
Yeah, so you convert the query into a vector as well, and then you kind of search for similarity from the database to the query vector.
Okay.
Yeah, so you just output with a very similar uh, yeah you just find the similar vector and output that. I'm pretty sure ChatGPT does something similar. If you go to ChatGPT and ask something like, summarize this archive paper for me and give it like an archive link. So let's say an archive link from like a few months ago, right, which it's not trained on. It'll find like in its vector database another archive link from when it was trained. So it might so archive links are like 2104.1234. So it might find like 2004.123 something like that. And yeah, so just something similar and output that. Yeah.
So something like some boilerplate cosine similarity between.
Yeah, exactly. So kind of like cosine similarity is one of the ways you can find similarities. Yeah.
Okay, awesome, thanks.
Yeah. Hi.
I've got a question on there.
Two questions. So for the, at least as of GPT-3, it leaned heavily towards English content, and I believe it's also true. Well, I'm not sure how true. I haven't checked how true that is of GPT-4, but based on your observations and going back to the idea of accessibility, how have you observed its performance in other languages other than say English and Chinese, like say Vietnamese, Thai, or Indonesian?
Yeah, that's a good question. Neither of us know any of those languages you mentioned. We've tried with Hindi and like Bengali, and Archana knows Tamil, so works pretty well on that. Yeah. Also, like we've just tried with very simple like business use cases. So not like really long texts or like articles or something, but like small paragraphs that you might write in an email or in a Slack message, something like that.
Yeah, and actually on that idea, so since the tool right now is primarily for translation, as the demo you're showing off, what was the consideration between just choosing the existing array of translation APIs out there, translation neural network APIs out there, versus like saying uses GPTs?
So I think like the translation is definitely like a part of it, but the idea is also to sort of use the sentiment the way that GPT was built. Like, because the fact is, it can formalize, it can change those tones really well. And that's what we wanted to capture, because oftentimes when you move from your native language to English, a lot gets sort of lost in translation. And we want to make sure that such users don't get left out as compared to people who usually speak English. So the idea is definitely translation, but an added part to it is this formalization. And I don't think there's an API that does all of that currently. And if there's something else on top as well we want, I think like OpenAI's like GPT API provides us that.
Or maybe even just to save cost, the translate function uses the cheaper translation API, and the formalization just uses GPT. Right? That would save cost.
I mean, the cost is like, we haven't actually seen the cost, right? Because we use GPT Plus and they give you like $18, right? So we haven't up to a large scale and we have more users using it, can we actually understand the cost?
Right.
Yeah, good, great questions. Any other questions from the audience? We got two experts here who've been playing with GPTs since the old days, which is a nice quote. Any other questions from the audience before we break for tea? Yes, please.
Hello, I'm from China, and probably, as you know, we cannot easy to access open API like ChatGPT in China. Sometimes we can find an agent. I try to use image search. Okay, I ask ChatGPT to provide some images, but I cannot get what I want. So, would you help to explain what's the purpose of what's the principles of the image generation in the ChatGPT?
Yeah. So,
Thanks.
we know that the latest version of ChatGPT can use images and combine images and text, but they haven't released that API yet. They've just shown us demos of it. And then there's other models that can do images and extract text from images and stuff like that. We haven't tried that yet. Regarding like not being able to access and all. Right now there are a few open source language models. The problem with that is it's very hard to host those models because you need a GPU. It's pretty expensive if you want to get low latencies. That's something we want to work on eventually. Yeah, but we're just figuring out the logistics of that.
Yeah, good. I think one of the big learnings there is, as you mentioned, on cost, is
Yeah.
it's easy and quick to play with GPT, but as soon as you want to go beyond just experimentation, then you've got to take these other factors into consideration. Still open for questions. Otherwise, of course, the speakers will be around outside and over tea.
Yeah,
So I think
we'll be in the event hall in the Women Who Code booth somewhere near there. So yeah, if you have questions, you can always come there. Yeah.
Okay, thank you so much, everyone. Great. So we'll resume in 15 minutes. So that'll take us up.
So happy to find the best drivers for you with Gojek and give you fashion advice if you need one. Yeah, welcome to this talk. Title of today's presentation is going to be Improving Efficiency with Prompt Engineering. And thank you for coming, first of all, and for taking your time here. And it's not going to be hardcore technical talk, but I believe it's going to be very important given the current situation and state what's happening with large language models. And the character here is AI generated, inspired by Gordon Ramsay. And I have him because secondary topic of today's presentation is going to be cooking. A few words about me. I'm Jan Idziak. I'm technical manager specializing in productionizing AI solutions, and I'm focusing on improving efficiency of the teams. So slightly different field now. You can find me on Twitter. I'm not that active. Later, I'll share with you LinkedIn link as well. This is my hobbies, practical Montessori. I work on handwritten text recognition as well, and technical stack. Agenda, welcome first, then I'm gonna talk about introduction to large language models and how people are using them. Then I'm gonna tell you how I was inspired to start using large language models. And then we're gonna go to the meat of the presentation, which is creating our own prompt book. And my friends that presented just before me shared the importance of having your prompts saved in some safe place so you can reuse them. And lastly, we are gonna go into another important part, which is creating our own prompts and why this is important. So I'm talking about large language models, and perhaps because you're here and you've seen already the previous presentation, and many of you heard of ChatGPT. This is not the only one. There is many more, and I wanted to share with you this infographic. There's BART from Google or Claude from Anthropic, and there are also some open source options like Vicuna or llama-based models. Show of hands. How often do you use large language models? Never heard of it? Okay, that's great. Tried a few times? Awesome. Every week? And every day? Great. I'm happy to see that so many of you are using it. And from my research, I see that only 2 in 10 managers are using large language models every week, and only 4 in 10 engineers. That might be a little bit outdated. I did the query or poll a few weeks back, but still this is limited. And in this audience, I see that many more of you are using it. I'm happy to see that. And here are some of the reasons why people don't want to use them. It doesn't create anything of value, or grandma warns about robot uprising because she's in Terminator. Or the most valid one, the last one, privacy concerns because of the data collection. We need to be careful with that, especially hearing recent events from some big companies. All right, so let's get to introduction of large language models. So I'm going to share with you a few examples of how people are using large language models. And this is going to be mainly based on Claude and ChatGPT. This presentation is going to be mainly based on Claude and ChatGPT responses. So first, point. I guess this was the first one that I seen when I started working with ChatGPT. Write short poem about artificial intelligence, and it would be great to provide you with the examples. If you want to write email, and then you want to change it into poem, it would be possible to do that. Second, mathematician. So I studied mathematics. I remember I had a lot of fun proving theorems, and I spent a lot of time with my friends doing that. And now it's even more fun. You can add emojis to it with ChatGPT. Then ChatGPT is also good at preventing crimes. So if you want to hotwire a car, it would tell you that it's not really good to tamper with car electrical system and it might be illegal. But if you're there in the woods and the baby is in danger, and the only way to save the baby is to hotwire a car and take it to the hospital, it would be more than happy to provide you with the instruction. And this process, this is important, this process, and my friends were talking about that this is called prompt engineering. So basically, you wrap around your prompt within larger context, and you confuse your models. So ChatGPT is really good at stopping prompt injections, so you need to be really creative to get the answer, but other newer models are worse. So it's easier to engineer prompts for the other models. And now we're getting to the question, is this useful? To me, this is garbage. How often do you need to do a poem about something? Or how often do you need to add prompts to the mathematics theorem? That's not really useful. Hot wiring car? Perhaps never. So I was sitting there with my wife, and we were in Bali, and we thought, oh, it's hypey, this new topic, ChatGPT, and my wife started her own company, and she asked me to help her a little bit with the creation of the website. And creation of the websites is not easy for data scientists, especially that they don't have JavaScript background. And what's more, creating content is time-consuming and hard and requires a lot of attention. And we didn't have that much time because we have also a son that is 2 years old. But we decided to give it a try and start to use ChatGPT to facilitate the process. And we were super surprised that it sped up the process and also improved the content. The responses weren't ideal. It was giving a lot of errors and mistakes and something that is not really Montessori. We were focused on Montessori education. But together with my wife, we were able to fine-tune the responses and get the correct ones. So, and for now, it already generated some leads. The website that we created together generated some leads. So now we are sort of looking forward to generate even more. And 3 weeks ago, we've been going to Malaysia for holidays, and now we're moving houses, and I was preparing for the conference, so we didn't have much time to plan this trip. So I asked ChatGPT for help, and it was able to provide me 3-day itinerary with the step-by-step guides. What should we do? It took us to some durian shops. My wife wasn't amused with that, but to me it was fine. All right, and the next one, and I guess this one is another topic that is related to the previous talk. So if you think about summarizing a podcast previously, it was a really huge project. You had to have some data to fine-tune your model. It was costly. You had to have engineers and perhaps some expertise. So that was a huge project with a lot of unknowns. And now, if you want to do the same with the use of some APIs, you can test the solution very fast. And what's more, most likely the results that you're going to get from GPT-3 or 4 are going to be much better than the ones that you're going to get from your custom-made trained BERT. BERT is old, state-of-the-art type of model. I guess it was published in 2018. So here we are. Those are a few examples how we save time or how we manage to do things faster. And what I'm saying is that you can do a lot of things that were previously time-consuming much faster. And you can get the results that are not ideal, but you can tweak them and you can speed up a lot of processes. So what I'm saying that is you can save time by using large language models as your brain scaffolding. You will never replace it yet. And all of that you can do to make yourself relevant. Because I believe we are not going to have this Terminator example that I was talking about and Grandma is afraid of, but we're going to have a situation where people who are using AI would be competing against people who are not using AI. And I don't have to tell you who is having head start in that race. And what is more, lastly, this is not 100% accurate, but it's fairly accurate. So introducing of ChatGPT, to me, is a very similar event to introducing iPhone or smartphones, because it enables a lot of previously impossible things a lot faster. So during iPhone release, we had companies such as Instagram or Square that were built on top of that. So for now, I see the completely new universe of application is going to be enabled. And already we see the trend, how Microsoft is using Copilot for PowerPoint presentations or Word documents. We see also the same for Notion. Even OmniOffice is using ChatGPT within their software. So yeah, I guess this is giving you good motivation to start your own prompt book, because that might be relevant. But you might still question why do you need prompt book, and I gave you a hint just before. But basically, I'm suggesting that so then you can reuse some of the prompts that you're using often. And you don't have to recreate the wheel, reinvent the wheel multiple times. How to use this presentation? From now on, this is important. I'm going to share with you some prompts and some answers. They're going to be truncated, so I'm not going to share with you everything because I want you to focus on how things are being made and not each word step by step. And I'll share the presentation after the talk, so you can copy-paste some of the prompts that I'm sharing with you. Some of the prompts were ones that I found on the internet, and I found them useful, and I keep them for myself, and some of them were invented by me. All right. So the power of prompt engineering. This is also another answer to the question, why do you need prompt engineering? And I'm asking questions to the ChatGPT. ChatGPT answers, and everything is fine. I'll ask complete the sentence. This is Claude, by the way, from Anthropic. I'll ask complete the sentence, life is like. And the answer is, life is like a box of chocolate. You never know what you're going to get. This is good answer. It's answer from Forrest Gump. I remember this movie when I was small and I was watching it multiple times. But it's boring. Everyone knows that. It's nothing inventive. And I can create it myself. You don't have to think much to create this answer. So how about if we ask model to behave like a Michelin star chef? So behave like a Gordon Ramsay and complete that sentence. And then it would say, life is like a bad risotto. Too many people don't steer enough, don't pay enough attention to the details, and end up with the mashy flavorless. Yeah, and I like this. I like this answer much more, especially if you like cooking yourself. And I'm sharing why cooking is secondary topic of this presentation is because cooking is much like prompting. You have your cookbook where you serve your recipes for later, and you can reuse them. And you can either use some recipes that someone else created, or you can create your own. And I'm going to talk about both of the things. So first, I'm going to show you a few pre-made prompts. Sorry. Okay, so cookbook or prompt book starter. Okay, and here I'm going to share with you only 3 prompts. One of the things that I started to do more when I started to be adult is answering emails. And my wife facing this even more often as she works as a teacher. And if you use ChatGPT, it can give you boilerplate message on how to reply to some email. And this is Alan asking about the AI resources. Here's the full answer, and here's truncated answer. And it provided me or the person who requested for that a lot of options for Jim to learn AI. It's very basic. You would have to still edit it, but the answer is very reasonable. You don't need to think, but you can think about deeper insights. And here is the template. So the template you can copy paste. Second thing, learning. Many of us want to learn new things. And previously YouTube was a big thing. And now I guess ChatGPT can accelerate that process as well. So here is the example. I want to learn about artificial intelligence, same topic. 20% of the topic that yields 80% of the results. Here's the full answer. Full answer was really long. It was 8 sections covering a number of things. But the main thing that I wanted to share with you, it suggested basics of machine learning basics. You don't see this. There's machine learning by Andrew and G. So it suggested lots of relevant sources as well to learn in depth. This is full prompt for learning. It's modified prompt that I found online. I'll share the presentation, so you don't need to take photos yet. And last one, I wanted to share with you the travel prompt. This was, I guess it was shared by generative AI. And make day-by-day itinerary about round trip to Singapore. You can also ask about hourly itinerary. And I asked about multiple food options. It's not really great with providing food options, but I was okay with that. Full answer and truncated answer. That's really cool. If you're visiting Singapore, I also recommend you to go to Kranji. You can see a lot of bird species. and alligators there. And it's worth it. All right, this is travel, full prompt. And now last part. I think, why do I need to create prompting? What is prompting? And why do I need to do anything like prompt engineering? And prompting is like simply asking questions. And prompt engineering is art of asking right questions to the right people to get right answer. And right answer is wherever you need. So framework, there is no single framework that is mainstream yet because prompt engineering is fairly new. But I decided to provide you one option for using it. And here it is. And basically, while providing framework, I want you to focus on providing a lot of context to the chat or to other language models. Because if you provide context, then it will be able to answer you with relevant response. If you don't provide enough context or the context is wrong, then it's more likely to give you wrong results. So the context that I suggest is task. So whatever you need to do. Second is role. So who needs to answer or to whom the answer is. The third one is constraints. So what chat should do or what shouldn't do. And the last one is chain of thoughts that my friends covered or examples. So you provide even more context by showing how the chat should think. All right, and let's get to the example. I'm hungry, it's late, and what should I do? Then when I was starting using ChatGPT, I would write, what should I eat for dinner? And it was fine. It created a few ideas, and I like the ideas. They're already good. Grilled salmon, I would eat that. Chicken, I wouldn't because I'm vegetarian. Vegetarian chickpea, not vegetarian, pescatarian. Chickpea, vegetarian chickpea curry, reasonable. I don't like chickpea that much. That's still fine. And now we're getting to the last example. So how, if we provide more context, I'm hungry, it's late, what should I do? And my girlfriend is there, and both of us, we have dietary restrictions, and I want to make it moment that matters. So instead of asking what should I eat, I would ask to design a 3-course menu that I can make at home. And also I will ask Gordon Ramsay or other Michelin stars to design that menu for me. And now about constraints, I have lactose intolerance and my girlfriend doesn't eat gluten. All right, so let's add that. And lastly, think about this step by step. And this is really important. This you should save. Don't answer if you're not sure. This reduces hallucination, so-called, by much. So this is influencing the thought process. And here is the answer that I got. And I was amazed. As a Michelin star chef, I would be delighted to create customized menu for you and your girlfriend. And it provided us with 3-course menu with ingredients and step-by-step guide on how to create them. So I guess this is a fairly convincing example on why engineering prompts is better than just prompting randomly. And then premium all-in-one example. So this is Inception. It's not really pre-cooked example, or it's not really engineered example, but you can ask ChatGPT to help you engineer your future examples. And I've been using that a lot. And I asked ChatGPT on how to amaze people joining presentation on prompt engineering. And it helped me in creating this presentation as well. All right, so let's get to conclusion. So I'm suggesting you to start your prompt book and use the methods that I covered here to automate some tasks that you're working on and in the effect to stay relevant. Thank you, it was a pleasure to talk to you. And now scan. This is the QR code to my LinkedIn post, and in comment you have the presentation link. And for now, the presentation is still closed because I didn't want anyone to see it before the presentation. And I will open in a few minutes.
Okay, wonderful. So we have someone who's played extensively with prompts, and your opportunity to ask him lots of questions on this. So,
oh, we still have time for questions. Awesome.
Yeah, so it's noted in the last presentation, there's been changes even within the model, the releases of GPT-3 and 4. So when we're going to scale, what does that look like? How are you, since they don't explicitly reveal to us like version numbers or versioning of GPT-4, how are you versioning these or like controlling these, so on and so forth, logging these?
So if it comes to using this, I'm trying to be very practical, and I'm trying to automate especially tasks that are time consuming, and I need to have starter code or starter template that I can later edit and adjust to my current needs. And for that use case, it's not really problematic whether the model results are consistent or not. If I get result that is from early stages of GPT when prompt engineering works, or this might be the only problem when the not prompt engineering but prompt injection works. But for email replies, for learning examples, or for designing trips, or for boilerplate code, for debugging code, for user story creation, for being creative and finding two concepts that are unrelated at the beginning and you connect them together. All of those examples are in the presentation, in the appendix. All of those, the responses in between the models wouldn't change much. They would be good. They were good, and I expect them to only be better in the future. They wouldn't block none of those use cases that are relevant. Yeah. Does that answer your question? Awesome.
Yeah, sure.
By creating prompt books, because there are a lot of online resources already, like for example, playground.ai has a list of prompts, right? So how do you recommend creating prompt books?
Awesome. Really good question. I'm happy that you asked. So there's tons of resources, and you would be overwhelmed with them. So I'm suggesting to create prompt book because there's lots of cooking books, and you don't use them. But my wife always had a small book where she saved all the recipes that she used often. So I'm suggesting you to create your own book with the prompts that you are using, and not to use generic results. Because if you use generic results, you would still need to search. So I want you to save the time of search of the prompts that you need and use often. Yeah, that's the reason for creating your own prompt book. And you don't have to have your own prompts. That's an option. Lots of prompts that I use in the presentation are from someone else, because there are lots of people who are working on that and they're creating great things. Yeah, this is the open source part of the talk. That's there. Right. Okay.
Yeah. It's a big room. So.
Hi, so thanks for sharing. I have two questions. So first is that, as we know, there is the whole AI, I think the whole large language model is evolving very fast. So we're having GPT-4 coming up, and I mean, it's already there. 5 is coming up, and we have other companies publishing their own models. So I believe you have definitely played with a lot of these models. So do you find the prompts like consistent? Like if you feed the same prompts to different models, do they still perform the same? And because I like your analogy of like the cookbook, but I mean, let's say the rice that we're using have not changed for the past 1,000 years, but models are evolving very fast. So do you find, let's say if you have a prompt book that's built using let's say GPT 3.5, and after 4 comes up, or if you're using other models, do you see any inconsistency in the results, in the quality of that? And my second question is that how do you, like, if let's say you're using the prompts for some tasks where facts are very important, then how do you do fact checking? Yeah.
Okay. Oh, awesome. Two great questions. So first, consistency, and then fact checking. Consistency in between the models. So there is one great thing. OpenAI have big budget and lots of people who are working on it, and they had head start. So lots of prompt injections are stopped, but other models don't do that. So you can do, you don't even have to do prompt injections for some models, for some newer models. You can just ask how to hotwire a car and it would answer. And again, similar answer to the previous one. For most of the use cases that I'm using, it's simple tasks that are time consuming. And even if the answer is slightly inconsistent between two models, it would provide you boilerplate. So you can reuse that and adjust it. And then fact-checking is a second question. So fact-checking and adjustments of the result, I guess they're related topics. So when we were creating the website for my wife, this Montessori website, lots of responses from the chat were inaccurate and were Montessori, and we are really into Montessori. So, and when I said that AI wouldn't replace us yet, and it's not going to be a fight between people and AI, but people who are using AI versus people who are not. So you still need to have an expert to validate some results. The prompt that I shared with you, don't answer if you don't know, it works to some extent. But sometimes chat would make up things anyways. And less powerful chats would make up more things than the other ones. So just be practical, use it to your needs, and don't go for the, I don't know, for people who are shouting, oh no, this created something that is incorrect. That's fine, it created, just take that into account and use it to the fullest. And don't lose your time on complaining that something is not ideal. And if you don't have expertise, find someone who has expertise and can validate this. And what you can do, you can ask ChatGPT, hey, how should I learn about AI? And then it would give you boilerplate, and you ask some of your friends who is AI, hey, I was thinking about learning AI. I have these ideas. What do you think? What should I add? What should I take out? And then it's much better than asking, oh, what should I learn about AI? Like, you're more specific with your questions to people who are experts, and then you're not wasting their time, and you're not asking them to, I mean, not really, it's not about wasting time, but it's like you're being more proactive than with answering more directed questions. Cool. So this is about fine-tuning and experts. Any more questions?
Really valid point. Maybe also a question of how we measure productivity going forward, especially where people are AI assisted. So very, very interesting question around the prompts for different models. Yeah. Still open to the floor. We got 2 more minutes before we bring up our next speaker. Or of course, Jan will be around to take the conversation offline.
Happy to answer more questions.
Yes, please.
Yeah, it's okay. It's better because people would hear.
Okay, this is coming more from the text to image side of things, because but it applies to ChatGPT basically. But so what's happening with text to image is that there's a lot of copyright issues coming up because when text to image, things like, Midjourney generate an image, is it copyrightable? What are the problems with training? Are we seeing the same issues popping up with ChatGPT type, text-to-text kind of models?
I mean, I believe yes. I believe there were even some legal actions related to that to slow down OpenAI. But I would need to double check. What's the current state of that. And I see some of the open source large language models who would use only open licenses to train their models. For some closed source, you don't know what the models are trained on, and they are not transparent. For open source, you see that, and also open source models would allow you to opt out from, like, if you're sharing your code on GitHub or whatever with open license, you can opt out from model training. But yeah, so this is for open source. And then for closed source, yeah, I would need to double check what is the current situation. And I think that there might be some legal actions similar to what's happening with the text to image. But yeah, we'll see.
Round of applause. Excellent.
Thanks a lot.
Machine learning in search, where we're working, has some unique constraints because we generally have a very high volume of queries and very strict latency requirements, like real time. A lot of machine learning is run in batches, like once an hour or so. But when you have to return things in real time with very large numbers of queries, things get a little bit more interesting. So I guess we'll give a little background about what Mercari is and the situation we were in when we introduced our machine learning model. So Mercari is Japan's largest consumer-to-consumer online marketplace, like an online flea market. Our vision is a circular economy, so sustainability. We want to reduce the number of things that go to landfill, reduce the number of new things we have to manufacture by allowing people to resell their things instead of throwing them away. Our net sales are about 150 billion yen, a little over $1 billion US. And within search, we have over 20 million monthly active users, so unique visitors to our website every month. Hundreds of millions of active listings in our catalog, and thousands of queries per second. And our all-time peak is over 10,000 queries per second. So that's kind of the landscape we saw when we had our first machine learning model that we wanted to put into production. Our initial original architecture was a traditional term-based architecture based on Elasticsearch. Elasticsearch is an industry-wide standard, very widely used, but it's term-based. That means that the keywords that you enter in the query are what are returned. So if somebody had not written that exact keyword in their description of their item, you wouldn't find it. So that was a big limitation of Elasticsearch, although it was still working very well for us for 10 years. But our challenge was then to take this traditional architecture and add machine learning into it. And so now I'll pass the mic over to Tio.
Thanks, Ryan. And so, as Ryan mentioned, my name is Tio. I'm going to be discussing the next part of our talk, which is the problem. So, as Ryan mentioned, we have this existing search architecture, but why do we need AI in this system, right? And so, while this was very effective, this was Mercari's search backbone for over 10 years, there were a few major shortcomings. So, Elasticsearch is a keyword-based system, and because of that, it kind of falls for things like this, right? So, these are areas where AI can help. For instance, ambiguous keywords, semantics, saying cool toys for boys, and personalization. And so with keyword-based matching, you can't resolve any of these issues. So again, going back to ambiguous keywords, in Japan, One Piece is a type of women's clothing, but it's also the name of a very popular Japanese manga franchise. And so if you're just using queries, matching the query to relevant items, which gets returned? Maybe both, right? When you only wanted one or the other, very different items. And then semantics, again, cool toys for boys. Maybe this One Piece bag is a cool toy for boys, but that's not in the title or the description, so it will never come up. And then personalization, again, there's no real easy way to personalize results to a user just based on a query itself. These are all ways that we knew AI-based methods could help improve the search that we had at Mercari. And so, the question is, where do we start, right? So we have an idea. Let's do AI in search at Mercari, but how do we do it in a world that wasn't designed for it? So the search architecture was designed originally without AI in mind at all, right? So there were no easy ways for us to integrate AI. And because Mercari is, again, Japan's largest consumer marketplace, at the scale that we had very strict performance requirements. And so our latency budget was, in our case, just tens of milliseconds, which is really, really tough for machine learning models. And we also didn't have access to, again, no easy hooks for AI, optimal ways of serving these AI requests, right? That's not really built into the search architecture. And so the final thing that we want to discuss is these are kind of like infrastructural constraints, but the main constraint we had was user search experience at all costs. So no matter what we do, the user search experience must be as good or if not better at each step of the way. And so we always want the situation on the right and not the left, right? That's exactly what we're trying to do by using AI to improve search results, right? And so this was the hardest part of the, I guess, the constraint, but I think it was the one that served us very well to deliver the actual business impact of our system as opposed to just say model performance or something like this. And so what is the first way that we decided to apply AI in search, right, with an existing search infrastructure that didn't have AI? So enter search re-ranking. This was the original place that we felt AI would add the most value, highest ROI, with the simplest, least intrusive integration into our existing system. And so our colleagues, Alex and Norbert, actually got into the ML side of this talk on, I think, Thursday morning, the second talk of the day. And so there's two aspects when you consider adding an ML system into an existing search architecture, where the Elasticsearch result, the original result that came back, can be considered the first phase of retrieval. And now we're adding a second phase where we can re-rank those results on top. And so essentially the goal is, we have this set of results. Can we surface the most relevant ones to our users first, which is even more powerful in e-commerce context, right? So when, say for instance, if you're on Google doing a Google search, maybe you have a little more patience to go to the next page, the third page for search results. But for an e-commerce platform, it's very crucial to have the most relevant results first. In the long term, which is ultimately serves our broader purpose of matching users to the items which they're looking for. And so with the first concrete use case for AI in search in mind, we go to the next step, which is the evolution of this ML system, right? So how do we grow an ML system while, again, running the business, ensuring a really high user search experience? And I want to emphasize that the focus is always on least risk, very iterative development on the highest ROI areas that we see in each iteration, and then going from there. And so, given our existing infrastructure, the first thing that we did was the simplest solution, which is if we do have a machine learning model, we can integrate it directly within the search server. And so this had a lot of benefits, but there were a few drawbacks. For instance, we tightly coupled model development with development of the search service itself. The code base is massive. We have many developers working on it concurrently. As you would imagine, such a key part of the Mercari platform. It has a very high release cadence, and so we had to be very careful when we were developing. Along the way, this whole journey was very measured. We wanted to make sure that we weren't able to provide major features out of the gate, but we also preempted any major incidents, right? So in production, we were running very reliably the whole time. So because of that, it made it very difficult. We went very, very slowly at this stage, but we went, right? This was a step in the right direction. And I do want to mention that because in keeping with the theme of this talk of open source, for each of these stages of system evolution, we wanted to just include one of the many libraries just to highlight that kind of brought us from that stage to the next stage. And so in this case, our search server is actually written 100% in Go. And so we're very limited in the libraries that we could use, but we did find a very useful one. This is called Leaves. And so in this case, we just developed an internal component that used this library to serve a light GBM model directly in the Go code in the search server. And so it was very simple to implement, as mentioned. It was just a function call right to this component, which served this model. With that being said, again, there were problems with this solution that we addressed in the next phase of the system. And so in this case, it was characterized by really us going all in on our microservices architecture. So Mercari is very, very heavily invested in microservices, very Kubernetes first company. And so it was very easy, a very natural choice for us to now split the ML model from the search server to a custom Python microservice for model serving, which was, again, very simple, but actually unlocked huge benefits. Now we could develop independently from the rest of the search team from that huge search code base. And again, originally it was just a function call to the model in the existing kind of search server. Now we just easily replace that function call with an RPC. And now since it's going over the network, we have a small timeout. And now we introduce the notion of a baseline response, which in this case is Elasticsearch rankings. And so what's very useful in deploying ML productions or ML systems to production is having some kind of really simple baseline that you can iterate on top of. And because we already have Elasticsearch results, this was the natural choice for us and went back to our do no harm to users kind of tenet, right? So by definition, if this re-ranking system was implemented, in the worst case, it would do no worse than what was already in place currently. So again, this key aspect of having this baseline response helped us to really iterate quickly in this stage and the next stage. And we also took the time to, as we're building out our POCs, to implement basic production kind of, in this case metrics, but production features that help us in the future. So in this case, we add more observability to our system, but we're constantly paving the path to a more production system in the future, right, along the way with each iteration. That wasn't strictly necessary, but we knew it was a good thing to do at the time and very natural, and wanted to emphasize that at these key points is when we add the complexity, because now we realize there's an actual need, right? And so in keeping with the OSS talk, and because we moved to a Python microservice, this gave us a lot more flexibility. And so using re-ranking, we went with TensorFlow re-ranking. TensorFlow, for those of you here who aren't familiar, is an open source library made by Google. It's been open source for many years now, industry standard in a lot of ways. High performance, it's been validated, has very active development. So again, a natural choice for us going forward and really kind of helped us to really get through this next stage successfully. And so with this being said, the system was still very basic and there are still many ways for us to improve on the system. And so this is the next solution that we settled on. And so as mentioned previously, the search server with the model baked in, features were computed within the search request. And so we realized a lot of those features were, well, the computation of the features was very redundant. And so if now we have, say, consider a feature store like a distributed cache for inputs for a model, and what we iterated on, which is kind of not present in the slide, I'll go over it really quickly, was again, very basic next steps. And so instead of computing features within a search request every time, now we can pre-compute them. In this case, we used a Bigtable, which is cloud managed on-disk storage by Google. That was a lot better, but it did not meet our current latency requirements at the time, reliably, I should say. And so we then upgraded from that to using Redis, which is an in-memory key value store. And it served the same purpose. We were able to keep the interface the exact same. And then that was the key to further improving the system's performance to meet the aggressive latency requirements that we mentioned earlier. And in addition, as mentioned before, we have timeouts on the re-ranking request. We also have timeouts and fail-safes on this feature store component. So we can get into it a little later. There's a few details in there. But essentially, with each abstraction that we added and each layer of complexity, there was always a safeguard to fall back to that previous more simple layer that we had before. And again, further improving our monitoring kind of observability suite along the way, realizing kind of what metrics we needed to track both operationally and for model performance. And it's worth emphasizing here that a major bottleneck that we now had is, again, I mentioned, oh, we're developing very quickly, right? That meant that we had to do a lot of A/B tests, which is essentially, you know, we have something that's in production, we run something that receives a certain part of traffic, this new feature, and we see, oh, does this feature raise any of these key metrics that we have that are related to the business? And because we were able to develop quickly, we were able to develop and test new features quickly. But now the bottleneck wasn't necessarily feature development, but it was actually the A/B tests themselves. So we could develop features very quickly, but each new A/B test required a new model, which needed essentially to be deployed as a new microservice and set up the same way as we set up the original model, which you multiplied by the amount of models in any given A/B test. So that was actually taking us about maybe a full engineer's time per quarter. And even with that, it would be 1 to 2 A/B tests maximum. And so that became the next bottleneck in this phase of our system evolution. And before I go on to the next phase, I do want to highlight the next open source library that we use that was very high value. Again, feature store we settled on Redis as the actual backing technology. And so very simple, it's just a Go Redis, which is the Redis client for the Go language. Nothing really special to say, which I guess is kind of the main point, right? The main emphasis was it just integrated out of the box really easily with our current cloud managed Redis instance, and it had really great performance. And so again, open source along the way. We didn't have to reinvent the wheel on this one either. And then finishing up with the systems evolution, this is the final iteration currently. We have many more in the future, but this is where we're at right now. Which is adding Selden Core for serving and Istio for model routing. And these together will alleviate that bottleneck that we mentioned previously. So instead of having to set up new microservices and Kubernetes configurations for each model that we're A/B testing and then tear them back down again, we can move all of that manual work and automate that. So the feature flags we mentioned earlier, those can get sent directly as is without us modifying any code. And then Selden can actually just, with Istio's help, route those to the correct endpoints. And we can just spin up and down A/B tests, hopefully, an order of magnitude faster. And so again, iterative development, this I think will allow us to iterate even more quickly and really help us to now not just develop the features, but A/B test them and now release them to really improve that user search experience a lot more. And in conclusion, we believe that ML enhanced search really is worth the effort. So if you have a traditional search architecture, ML can really add a lot to that. And I can't really get into exact numbers to show how worth the investment it is. But as Ryan mentioned earlier, our annual net sales are on the order of $1 billion. So even just a 1% improvement in that direction is pretty significant, right? And so again, this went back to our very iterative approach to this system. So 1% decrease would also be horrible, right? But at the same time, because we went iteratively along the way, we were able to prove our system out, release it to production, and have positive lifts. So it definitely was well worth the investment in our case. And we would consider, we'll urge everyone here to consider a top-down integration of AI, right? So while it would have been possible to totally rewrite this architecture and re-implement it from scratch, that would have been really dangerous. And I can't feasibly think of a way to do that that wouldn't have negatively affected our users. But with a top-down system, we can slowly integrate into search. And now, over time, you have an AI-based search system that is essentially as if you were written it from scratch anyway. And again, in doing this top-down integration, this iterative development, you can really balance that engineering business trade-off, which if you go in this way, we think maybe very rapid iterations. You can start with the simplest, highest ROI features first, and at each step, just kind of lay that minimum amount of groundwork necessary for the main stage. So don't over-engineer your systems, but at least a little bit, make it extensible so you can evolve to that next, overcome that next bottleneck that presents itself. And then I wanted to finish off with this quote that I really like personally. It's from the great John Maxwell, which is, one is too small a number to achieve greatness. And I mention that because at Mercari, one of our values is an all for one. Literally, it's all for one. It means just teamwork, everyone helping each other. So a system at this scale would not have been possible without the help of many, many teams across the organization. So I wanted to say thank you to them. And to give back in keeping with that spirit, we're also building this system to serve search in general. So it started with our smaller team that was in search. Now a lot more search engineers can be empowered to add machine learning to the overall search system at Mercari. And once that's in place, we are aiming for an organizational-wide platform so that really AI can permeate much more easily across the org and reach its way to all of our users. And so, again, in all for one, one is too small a number to achieve greatness. We wanted to thank the open source community. So as we wanted to emphasize along the way, this wouldn't have been possible without open source, right? Mercari, search ML at Mercari would not have been possible, at least at this speed, with this quality, without the open source software that we use. It's almost entirely built on open source libraries. And in keeping with that, we at Mercari also open source our internal tools and resources back to the community when possible. In addition to, as engineers, contributing PRs and bug fixes to the libraries we use. Because Mercari was founded on the premise of a circular economy where everyone can buy and sell. We also believe in a circular development economy where anyone can contribute and hopefully anyone can build these scalable ML systems without having to be at the scale of Mercari. And so we wanted to give back to that and really kind of pay it forward. So we believe open source was the key differentiator in our case. And we really hope that the information in this presentation was valuable to the open source community present here today. Thank you for listening, and we are excited to answer any questions that everybody may have. Thank you.
Rick, so some questions for Rick and Theo?
Thanks for the sharing. So I just have one question about the search method that you're implementing. Do correct me if I'm wrong, but you're actually using the ML models to re-rank the results based on your original results. Yes. So does it mean that it will, in most cases, be slower than your original method without the ML models in actual product?
Yeah, exactly, 100%. And sorry, what was your name one more time?
Sorry?
What was your name again?
Billy.
Sorry, one more time?
Name?
Yes.
Billy.
Billy.
Yes.
Yes. Okay, yeah. So that was a great question. The short answer is yes. And that's what led to our strict latency requirements earlier, is that we kind of did the bookkeeping and said, this is the only permissible amount of latency that can be added to the existing system, right? The current latency metrics that the system without AI was performing at.
Thanks. I'll just add to that. We did some experiments to determine how much extra latency a user would tolerate. And we found it was pretty low, but not zero. So that was our opportunity to add in re-ranking on top of the existing system.
Would you mind sharing what are the common metrics you look at when you perform the A/B testing for your new model?
That is a good question.
In general, we could say our business metrics were sales. So the more we sold, the better that our product people were happy.
Hopefully that answers the question. Yeah.
Yeah, I guess that testing or that validation you only get once you put it into production, right? So perhaps to your question is how do you test that in advance to know that you're not going to miss the mark once you roll the model out? Yeah. Okay, so just pass it back first.
Hi, would you be able to share a little bit on the SRE side and all the performance, redundancies that you have to put in place?
Sure, we'd love to. Is there a specific area that you're considering?
Yeah, like I guess that you probably have multiple Elasticsearch instances. You will have multiple models because if one of the models went down, containers that contain the model, then how does that look? How do you do the upgrades and things like that?
Sure. Yeah, great question. So we actually run everything in Kubernetes, including Elasticsearch was a little maybe non-standard these days. But yeah, everything is in Kubernetes. We do canary deployments and rolling updates of our models themselves. And so if they break, we can quickly roll back. And then we use Datadog for monitoring our various metrics, latency, QPS, those kinds of things. And we get alerted sometimes late at night when we're not meeting our metrics. So it gives us a good incentive to not go too slow. Yes, but does that answer your question? Yeah. Yeah, so our main state is our feature store. So we compute features about our listings and we store them in, like Tio said, in memory store. We update it regularly. So in addition to caching them, we directly compute them offline and write them to our store. And that is the only stateful part of our system.
Thanks for the question.
I think there was a question in the front, two more.
Thanks for sharing your experience of you integrate your machine learning model with your search system, right? And you mentioned you use Microsoft and you use Kubernetes, right? So would you please share more details about how you use Kubernetes to organize your microservice? Thanks.
So that's a good question and maybe a better question for our platform team. So I can only really give you at a high level how we use Kubernetes internally. Is there a specific, I guess, question within that you were thinking of, a specific topic?
So my question is probably my question is you mentioned you use Kubernetes, right?
Yes.
To organize your microservices. So
yes.
I say, would you please just share more details? How do you use your Kubernetes, to organize your microservice for CI/CD or just very quickly to very quickly to change your system to implementation your system? And share more details about that.
Sure. I can try to give a kind of a high level. So at least from the ML productionization side of things, it's a very simple solution where we just create another set of Kubernetes manifests. We have kind of an automated templating system internally that will help us to do that. So in our case, as mentioned earlier, when A/B testing these models, there's a lot of kind of manual setup of these manifests. And honestly, a lot of it was a copy and paste and just change a few fields here and there. And so I think that's the system we were trying to solve. So short answer is, again, maybe not at the right level of abstraction, but we would just, for the ML models themselves to create different microservices, we have just a set of manifests we use customized on top of that, and then we just run it for a new set of manifests for that model.
Thanks. I'll add to it maybe a little bit. So like we said originally, the system wasn't designed for ML. And so it was a very kind of static system and endpoints don't change often. And so most of the endpoints were hard-coded. in various configuration files. So our entire Kubernetes configuration is a GitHub repo. And if you want to change the system, you make a PR. So if you want to add a microservice, it's a PR. And when we first started, it would be, we have to change almost every part of the system to manually code where the endpoints are. And then we would have if statements in our code to switch between which model to serve. So that wasn't, it wasn't scalable. So what we did now was we're using Istio for routing. So we just put the feature flags into the headers. And with Istio, we just allow Selden to route the request to the right model. And that allows us to serve a new model without changing any part of the system. The system just, the search server just calls the same endpoint every time. And depending on what the feature flag headers are, Selden decides which model is going to serve that request.
Interesting, yeah. Good. One follow-on question.
Yeah. May I ask, how does this search AI model in general support pagination?
Sorry, can you say that one more time?
Pagination.
Pagination.
Yeah.
That's a good question. So again, we worked with the existing search system. So whatever the pagination that was used within the search server is what we ranked on top of. And so we can't get into too many details, but essentially we had to re-rank with that pagination in mind. There was nothing special on top of that. Yeah, short answer. So hopefully that answers the question.
Yeah, thank you very much for the sharing. I just want to ask more regarding like the feature store. This is a bit interesting. Can you just elaborate more on how are you guys using the feature store? Is it used for to save the results for like the feature extraction from item descriptions, and do you use that for model training mainly, or does it come in place? Like how does data flow in this system? Yeah, in this case.
And I can get to it at a high level. So the short answer to those questions is yes, right? For all of the things. So primarily in the very beginning, there were some features of the model that, again, they were being computed within the search workflow itself. And some of those were already kind of just there, right? Like say, like, let's just pretend item name, right? We don't need to do any processing for that. It's just there. But there are other features, say maybe, clicks on an item, right? Let's just pretend that's one of the features in the feature store. And so those were the things that I realized, oh, like, that isn't feasible to really calculate within a search request. And so you can easily look it up if we have just a feature store. So that's how it started. And then the yes to all the other questions that you had is we are evolving it to serve many more complicated features after that have to do with both items and users. And then,
I'll elaborate a little bit. So the first features that we get back is what we get back from Elasticsearch, things about the item. What's the description? How much does it cost? Things like that. How many people have clicked like on it? And there are some things that we can't calculate just from the item itself, like what's the click-through rate that Tio mentioned, things like that, or personalization, like what does this user prefer, things like that, that we can't calculate just from Elasticsearch. So we pre-calculate it, and it's also the same things that we feed to our model, of course. And then at query time, we look those up in the feature store and feed the things we get back from Elasticsearch together with the features that we computed, feed them into the model, and we get a re-ranking. Does that make sense?
Okay, I think we're up for time, but thank you so much, Rick and Ryan. Rick and Theo, thank you so much. Very good.
So today this talk is about how we have built out scalable and robust near real-time machine learning models at Episos. So Episos deals into healthcare analytics, and I'm a part of NLP team into the Episos. So the talk will in this talk we'll focus on how we have built out the specifically for a near real-time machine learning system, how we have built out pre-computation feature pipelines, and what is the ML serving platform that we have used. So here's a little about me before we move on. I'm a lead data engineer at Episos, and so far in my career, I have worked in building out distributed data processing pipelines, machine learning systems, and setting up MLOps practices in the team. So the agenda of today's talk is that we'll start first with the challenges that we have faced in building out the one of the recent ML pipelines for our team and for Episos. And then we lead to that how it has lead with the idea of building out a pre-computation feature platform, dwelling into what ML serving platform are we using, and then ultimately going to the complete overview of the ML model server pipeline at Episos. Okay, so this this ML pipeline that we are talking about, that started when the data science team at our organization came up with the problem statement of deploying transformer models. So specifically this talk will focus on how do we deploy the complex models. When we are saying complex models, when they introduce the transformer models, we pick up that model and deploy it into that time current ML serving pipeline that was like more of a real-time type of API systems. So we deployed that specific transformer-based ML model into our pipeline, and what we saw that we are facing high latencies. When we are saying high latencies, they were more than a couple of seconds. And if we are leading into a API type of framework, if we are having high latency of more than seconds, then that is where the problem is, and you can't take up to such a model to a production. And when it comes to complex models, what an essential ingredient is that you have to use GPUs, and GPUs are really expensive. So if we go to the first point, which is the high latency, suppose if I'm getting high latency, one simple solution is that I add more replicas to my API and make the system more scalable. But now when we are talking of GPUs, we cannot scale to GPUs directly from say tens to hundreds just to serve more load, because that will then go over budget of our whole computing load. So that was the first problem that we are seeing. We were seeing high latencies, and we wanted to scale up to the incoming load that we were getting to reach back to the serving time into milliseconds. And the next problem that came along was that these model sizes were too large, so they were into GBs. So the one model that they came up with, that the size itself of the model was going up to 4 to 5 GBs, and the usual way of deploying machine learning models into production, at least at our organization, is wrapping up into them into containers. So once your model is wrapped up into a container, the whole Docker image size goes up to again a size of 10 GB. So if we are talking about scaling the API replicas, so first I have to scale the GPU machines. So if you have already worked on cloud and seen that if you even scale from 1 to 2 GPU machines, the time it takes for to get a GPU machine is approximately around in a range of 4 to 5 minutes. And then if your Docker container image size is going up to say 10 GBs, then the time only to bring up the whole container will again take additional 3 to 4 minutes. So it means that for me, the time to bring up one more replica was going around 9 minutes. So if I, and at episodes, we always believe in scaling up the load as per, scaling up the infrastructure as per the load itself. So we don't overscale and always have our architectures cost optimized. So we have to make sure that whenever the load is coming up, first we do the calculation and then scale the instances accordingly. So over here, if I am seeing that to bring up one replica, I'll need 9 minutes, then that will additionally add to the first problem that we have, which is the high latency for serving out the request. And into the whole NLP engines, there are multiple machine learning models that are working together to bring out the outcome. So we have to make sure that we are not losing data across the models when, say, a request or a data is going from one model to another. And the data, one of the feature of the whole machine learning pipeline is that we should have the data lineage management. Whenever a request is going from model 1 to model 2, we should know that what was the state of the request, was it success, was it failure. So this was the last challenge that we had in designing our ML pipeline. So over here, the first problem is high latency for inference tasks. So we picked up the task of going deep dive into what happens to an inference task. So this is just a general overview of that. Whenever we have an inference task, we get a data. So for us, since we are on AWS cloud, I have shown an S3 bucket for that. So we get the data on an S3 bucket. We pick up that data, we do data pre-processing, and then from that we go for a feature generation, load the model, embed the features into that model, so do the input processing, and then ultimately model gives out a prediction, and then we upload the prediction and do post-processing into an output bucket. So these were the broad steps of an inference task. And if you see, and what we notice is that the first two tasks, which is the data pre-processing and feature generation, they both were CPU-based tasks. And still they were happening into a GPU-based machine. And they were taking approximately 30 to 40% time of the total inference task. So what was the first conclusion that we came out after deep diving into this one is that we have to remove the first two steps out from our inference task and make it more of a pre-step to our inference task. So that gave that gave generation to the idea of the creating a pre-computation feature platform. So over here, whenever data comes up, first we do the feature computation and then only embed the request to the model and then get the prediction. So first, let's talk about the pre-computation feature platform benefits. So now when we have, and since like I told that we have multiple models working together to bring out the predictions on a piece of data. So there are also chances where these models are sharing few features. So over there, we have reduced the computational load. So if you have, in the last talk also we saw the mention of feature store. So in those feature store, we are first generating all the features at once, storing over there. And then in the model, we are retrieving those features as and when which model require which particular feature. So it has overall reduced the computational load for each request and the resources needed. And since we are removing and pre-cleaning our data, it has improved the accuracy at the model side. Yeah, the next benefit is that it has increased scalability. because now we are reusing features across the models and not generating for every time we are sending a prediction request to our model. And since we now, in terms of inference time, since we have now moved this whole process of generating features out of the inference task, we are saving directly 30-40% inference time on that side. And which means that we are actually saving 30-40% of our GPU time and GPU cost. So now over here, we have seen that we have moved out the feature generation part to a feature platform. The next step that comes out, that what will be our ML serving platform. So now since we have the whole architecture that will look out in the end, we'll see that the the latency was still coming around in not like a few milliseconds, but that was still coming around 1 second or so for this complex model. So we were very clear that we can't go with a real time of paradigm. So at this point, we were clear that we have to go for a async type of API paradigm for our ML serving platform. So after performing experiments on Cortex, open source Sheldon Core, and AWS SageMaker, we came up to a conclusion that AWS SageMaker is fitting the whole problem area that we are trying to solve. And also we believe in keeping our team lean. So what we wanted was that if we have a managed service, so that our engineers spend less time on maintaining the infrastructure rather than innovating on the infrastructure side. So what we needed in our ML serving platform was that it should have support for complex heavy models, and it should be able to first save the models even outside the container, and then help us to retrieve there. So SageMaker has its own SageMaker model registry where you can keep your model outside the container. So now we have the container size or the Docker image size is not comprising of the model size, which is an advantage over here. Tolerate high latency inferences. So for this, we were sure that we can't do with the real-time APIs, though the real-time API of SageMaker also was giving us result. But we always believe in scaling from 0 to 1 whenever there is load, and not keep the resources up whenever there is no load. So SageMaker asynchronous help us over there also. And in terms of SageMaker asynchronous endpoints, the way it deals with, it has its own internal queue. So you have to just invoke the asynchronous endpoint. It will first save your request and then do the inference and then save your output to an S3 bucket again. So it has its own internal queue, and the way it scales out, you just have to define your own auto-scaling parameters. In terms of data lineage management, there was no direct support from the SageMaker side. So we have built out our own pipeline to support the data lineage management. That we'll see again into the next slide. Scalability, reliability, and security, that is all guaranteed under AWS service usage. And in terms of cost optimization, specifically with the asynchronous type of endpoints in SageMaker, you have the flexibility of going from 0 to 1. So suppose there is no load at this point of time, then you can keep your instances at 0, and whenever there is a load, and since the star feature of asynchronous endpoints is that it has its own managed internal queue. So first, when your request will come up, it will go into the queue. The SageMaker, depending on however you have defined your auto-scaling policies, it will bring up one GPU instance, and then your request would be served. So now, even over here, the whole GPU provisioning time is coming around 4 minutes, because that's how the cloud, so because that's even the cloud provisioning logic. But over here, you have the flexibility of saving your request till the time it is not being served or inferenced. Okay, so this is the complete overview of ML model serving pipeline that we have built out at Episodes. So we were talking of the feature store and building out a pre-computation feature store platform. So over here, you see that we have built out Apache. We are using Kafka over there to first save data event points, and then compute and then consume those data event points to bring out the features from that data points, and then ultimately save again the feature events to a feature store or directly to the S3 bucket. Once you have the feature pre-generated, we have integrated the Lambda to listen to the Kafka topic, and then it picks up the data points from there and pings the SageMaker, Amazon SageMaker async endpoints. And with the SageMaker async endpoints, you have the flexibility of delivering your result status to SNS topic. So over here, for say you're sending a X request to endpoint A. So whenever that request is say failed, success, whatever the state of that request is changed, you will get a notification on a SNS topic. And so now for the data lineage management part, you are getting all the information into that SNS topic. So we can directly consume that SNS topic and pull out the information and drop it into a database, so that where machine learning engineers can directly query the database layer to know that what was the status of their request. In terms of near real time, because since nothing is happening in real time, but what we have kept is that the whole architecture is more of an event driven architecture. So as soon as your data is dropped at the event topic, the whole pipeline is triggered for that particular message. So that's why it's a near real time architecture. Yeah. And in terms of data storage, we are the SageMaker async itself uploads your inference output to an S3 bucket. So that's how we are dealing with the data. Yeah. So that's the complete overview of how we have built out the ML serving pipeline at Episodes. Thank you.
Oh, is that?
Yeah.
Okay. Great. Thank you. Thank you so much. Yeah, we're just coming up for time, so I think that was a good walkthrough of your technology approach to this challenge. Just before we step out, though.